I'm going to prove this trig identity. Okay, I put the identity table over here on the right to help me remember those. I eventually want to get those in my brain. When I look at this trig identity, I want to change stuff on the left. I don't want to change the right. Okay, when I look at the right, I see it's a fraction, right? So my brain says, I bet this somehow needs to go into being a fraction at some point. My general rule is I try to change things on the left to be sine or cosine. And I look over here and there is cosine over here, which tells me I'm on the right track. So I'm not going to change the cosine x right now. But what I can change is this secant x. And I look over here and secant x is 1 over cosine. So I'm going to change that to 1 over cosine. So I'm not going to change the cosine x, and then I'm going to say minus 1 over cosine x. All right, I'm not going to touch the right side. Now I'm going to look here, and I'm going to use my fraction knowledge. So what I'm going to do is I'm going to make a common denominator. So my denominator here is cosine x, so I'm going to use cosine x as my new denominator. So if I put and make this have a cosine x, that means that I multiplied the denominator by cosine x, so I need to multiply the numerator by cosine x, so that's going to give me cosine squared x. All right, I don't have to change this one, so I have that. Okay, now I'm going to look at that stuff. All right, and now the idea is, since this is my common denominator, don't want to do that. So since that's my common denominator, I can just put all the numerators together and hold it over cosine x, which will give me cosine squared x minus 1 all over cos x. Okay, which if I look, that's exactly what I was trying to get to. So I've just proved that identity. All right, I'm going to prove this identity now. This one has squares in it. So what I want you to not get bogged down by are these squares. So they don't really, you'd use the same concept as anything squared. So don't get bogged down by that. So again, I'm going to use my identities over here, and I'm going to try to rewrite over here. I'm not going to touch the right side. I'm going to touch the left side. So I'm going to try to change things to sine and cosine. So it's already in cosine squared over here on the left, so I'm not going to change that. But the denominator, I'm going to change cotangent. All right, now I'm not going to change cotangent to 1 over tangent. Okay, I'm not going to use this one. That's not helpful. Most of the times you're not going to use that. But I'm going to use this one here that has cosine and sine in it because I want to get cosine and sine in my problem. So I'm going to change cotangent to cosine squared x over sine squared x. Okay, so cotangent squared x is the same as squaring cosine over the square of sine. Okay, so that's the only thing different about the fact that there's a square in there. All right, now I'm going to do my algebra. Okay, so this is just a fraction. So this is this cosine squared x divided by cosine squared x by sine squared x. So when I do division, I'm going to just multiply by the flip. So this is just going to be cosine squared x, and I can put it over 1, and then I'm going to change it to, and I'm going to flip this. So sine squared x all over cosine squared x. Okay, now look at what you have, and notice this and this. So that means we can simplify those guys. So I'm going to cross those guys out. Oops. And they are gone. And I am left with sine squared x equals sine squared x. And that's exactly what I wanted. So I'm done.